Have you ever wondered why some objects roll faster even though they start at the same height? In this experiment, I'm going to raise two rolling objects at the same ramp to see which is faster. So today we're going to talk about the moment of inertia. It is the product of the mass of an object and the square of the perpendicular distance to the axis. So if you're going to put it on the formula, it will look like this. So the moment of inertia is the measure of how the mass is distributed along the axis of rotation. So the farther the mass is from the axis of rotation, therefore the larger the moment of inertia and the harder the object to spin or to roll. So these are the things that I'll be using. Wheels. The first one is a bicycle wheel with spokes. Most of its mass is on the rim, but the spokes are very light. This makes it behave like a tin hoop. Then next is a motorcycle tire without a rim. This is basically a thick rubber ring. Its mass is distributed a bit closer to the center. So compared to the bicycle wheel, it behaves less like a perfect hoop and a bit closer to solid cylinder. Since we don't have table scale and we only have mechanical weighing scale for a human that isn't working for the wheel, that's why we're going to weigh ourselves first, and then next is we're going to weigh ourselves along with the wheels and subtract it. So 49.40 our weight. With bicycle wheel, 51.65. With motorcycle tire, 52.30. Now we're going to get the distance of the mass to the axle. Since we are talking about how far that mass is from the axis of rotation, then we're going to get the radius. So first I get the 25 centimeter, but we should be sure, so that's why I get the diameter also that it should be 50, because diameter is equal to radius times 2. And now we're going to proceed with the tricycle's wheel. Since tricycle wheel doesn't have an axle, that's why we're going to get the diameter instead to get the radius accurately by dividing into 2. So we get 35 centimeter diameter. So now we're going to calculate those numbers that we've got earlier, the weight and the distance. So my weight earlier is 44.40, and with the first wheel or the bicycle wheel, we do get 51.65, and for the next wheel, second wheel or the motorcycle wheel, we get 52.30. So to get the specific weight of them, we're going to subtract it to my weight. So the first one is 51.65, the weight of the first wheel, minus my weight. Then what I've got is 2.25. The total 2.25 is the weight of the bicycle wheel. Then next is the bicycle wheel is 52.30 minus my weight. Then I get 2.9. So that is the weight of the wheel. Next, we are going to get the radius or the distance. Earlier, I got 25 cm for the bicycle wheel, and for the tricycle wheel, I get the diameter, which is 35 cm. So I will get the radius of it by using this formula. R is equal to T divided by 2. 35 divided by 2 is equal to 17.5. So that 17.5 is the radius of the wheel earlier. Then now we're going, since what we get centimeter, it should be meters, since that is the unit of for the radius. I'm going to put the centimeter on the denominator to cancel it, and we got 0.25 meter and 0.175 meter. But before we start, let's ask my father which wheel do they think will roll faster. Seriously, now we're going to check the two wheels, test it. Since we don't have a long ramp, it's kinda hard to see the difference between the two wheels. That's why I'm gonna do one by one. I'm gonna slow-mo it to 0.5, then check on the lap. For the first lap, we have 4.76, and for the bicycle wheel,
we get 5.07. So now we're going to explain it with the help of our equation I is equals to mr squared. But on the second wheel, we're going to use I is equals to 1/2 mr squared. Why? Because the more mass is concentrated at the rim, the bigger the inertia. On the bicycle wheel, all of the mass is in the tail end, like some of it. That makes it like a big wheel. But on the second, the motorcycle tire, the mass is only at the edge and spread out through the thickness of rubber. That makes it closer to the solid cylinder. That's why we're going to use the I is equals to 1/2 mr squared. So for the first one, we have I mr squared. The mass is 3.25. That is the bicycle wheel, 0.25. And then the distance of this, we go to square it, we got 0.0625. And then now we're going to multiply the two. We got 0.140625. As a motorcycle tire, we have 0.5 from the 1/2, and the mass of it is 2.9 earlier. The distance is 0.175 meter, then we're going to square it. We're going to square the 0.175 and we get 0.0806. So the 1.45 comes from 0.5 times 2.9. Now we're going to multiply the 2. And we get 0.044. So in my calculation, we can notice that the first wheel have a higher moment of inertia than the second. The first wheel is the bicycle wheel and the second is the tricycle tire. Since the bicycle wheel has a larger moment of inertia, it resists changes in its rotation more strongly, which means it needs more energy to spin. Then on the motorcycle tire, it has a smaller moment of inertia, so it is easier to rotate. So now we're going to do the checking by using the ratio. The formula for that is I is equals to mr squared. It tells us how the object's mass is distributed. So the answer for it should be 1, since it has the large ratio, that's of mass far from the center. And earlier for the bicycle wheel, we get 25 centimeter for the radius only, not a diameter. And there, we get 0.9999 or 1. Next, we're going to get for the tires ratio. I'm gonna use the same formula again. So the answer for that should be 0.5 since it has small ratio. The mass is closer to the center. Like earlier, we get 35 for the diameter and for its radius is 7.5. It is much smaller than the bicycle wheel. We get 0.4999 or 0.5. So that's all. Thank you.